What's up, everyone? Welcome to another episode of Code Porn. In this episode, we're going to learn the basics of Git so that you can get your projects under source control and work with and contribute to remote repositories. Now, Git's not new by any means, but most developers that I encounter have never heard of Git or have never used it. Now, since I live in the Microsoft world most of the time, I hear a lot of complaints about TFS, which is Microsoft's Application Lifecycle Management Suite, which also includes source control. I personally think TFS has a lot of good offerings, including their source control. It's very developer-friendly, team-friendly inside of the enterprise. But outside of the enterprise, it can be a little overkill for the individual developer and for projects with multiple disparate contributors. But when I ask these teams who use TFS, what would you rather use instead? I usually hear something like, well, Subversion, or SVN, as it's also known. I personally hate SVN, but when I suggest Git, I usually hear the same response. Well, Git's too complicated. It's too hard to learn. I don't really understand it. Now, that's obviously a response from someone who has never seen Git in action, because Git is actually very easy to use and learn, and especially considering how powerful it is. So why don't I go ahead and show you what I'm talking about, and let's jump into the demo. So first thing is to install Git. You can download the latest version of Git at git-scm.com. For this video, I'm using Windows. If you're on another setup, just work on getting Git installed. The usage of Git will be the same no matter what system you're on. During the installation, I recommend the default settings here on this screen. As far as your path settings, choose whatever you like, but I usually go with use Git from Git bash only. For line endings, I recommend sticking with the first option and let Git convert line endings for you. Once the install is done, it's ready to use. We're going to start off with local repositories and learn the basics before we jump into remote stuff. So we'll open up the Git shell by right-clicking on a folder and selecting Git bash. Notice the Git GUI option. I won't go over that here, but you should check it out once you're familiar with the basics. Git bash is a command line environment where you can type in the commands to control Git. Our first command will be git init, which will initialize a repository in the current folder. You can initialize a repository on a new folder or an existing one. So if you already have a project, you can go ahead and get it under source control, all the same as from starting from scratch. After the command finishes, you'll see a new hidden folder called .git, which is where Git stores everything including change sets, branches, and so on. At any time, you can delete this folder to destroy the repository. Of course, you'll lose all your change history by doing so. This also means that even though you're working under change control, it isn't a backup. Unlike TFS and SVN, where you're most likely checking into a remote repository somewhere on some server, Git uses a local file-based setup, and you'll need to back up manually or commit to a remote repository. But this also means you can zip this folder and send it off to anyone, and they can have immediate access to the repository as long as they have Git installed. At the moment, we don't have anything to put under version control, so let's create a text file. Now, even though the text file exists, it isn't being tracked by Git yet. We can see this by using git status to see where we stand at any given time. Git status is telling us our README file is untracked. So let's fix that by typing git add readme.txt and pressing enter. Now when we use git status, we see that our README file is ready to commit. This is called staging. We've staged the README file for a commit. But what does that really mean? Let's edit the README file again and see what happens. Now we see that readme.txt is under both tracked and untracked. But why? It's because when we staged the file using the add command, Git staged the version of the file as it was at that time, which only had change 1. So if we did a commit right now, the commit would not include change 2. We would need to use git add once more to stage the new changes. Once we've staged our changes, we're ready to commit them to the repository. We can do this using git commit. When we run git commit, we'll end up in a Vim-like screen because Git wants us to enter a commit message. This can be a bit confusing at first, but let's run through it and I'll show you a shortcut after. To enter a commit message in this Vim screen, press I, which puts you into insert mode, and then start typing your commit message. All of this text here is what Git has put in beforehand automatically to tell you what is being committed, just as a kind of a reminder. Notice that each line starts with a hash. This means those lines will be ignored and won't end up in your actual commit message. Once you have your text in there, hit the escape key to exit insert mode, and then type :WQ in lowercase, which will rewrite the current file and exit, causing Git to finish the commit. If we use git status once more, we see that there are no more pending changes, which means they were all committed to the repository. Now, if you're not Vim inclined, like myself, then forget about this screen. Let's make another change and try another commit. This time we'll provide the -m switch, which will allow us to provide a commit message right in the command line. So we'll type in git commit -m and then change 3 inside of quotes. Now we don't have to bother with that Vim screen if we just have a simple commit message. At this point, we have 2 commits in the repository. We can see the commit history using git log, which will list out the commits and their details like the author, date, and commit notes. This will be very useful when you're working with other developers. Let's add a new index.html to our project. Now let's make another change to our README file. Using git status, we see that we have changes to the README file and a new untracked file. We need to stage these files and changes, which we'll do using git add. But this time, instead of specifying each file name, let's stage them all at once. We do this by using git add followed by a period, which tells Git to stage everything. Additionally, we can specify a wildcard pattern like star.html, which will stage only files with HTML extensions. This is much easier than doing every file one by one. But there will be times when we don't want to include certain files in the repository. For example, if our application generates log files, we might not want those to be tracked in source control, and using a wildcard git add command would actually add those files. So let's simulate that by creating a new log file. Git status shows the log file as untracked. If we did a git add, the log file would be staged along with the other changes, which isn't what we want to happen. We can tell Git which files to exclude by creating a .gitignore file, which we'll use to specify files and file patterns for Git to ignore. Now the problem with doing this on a Windows machine is that you must type a file name when creating new files in Windows Explorer. So a shortcut to use is inside of the git bash, touch.gitignore, which will create the file for us. Afterwards, you can open it in an editor. In the editor, we'll add star.log and then save the file. Now when we use git status, our log file doesn't show up any longer. However, our git ignore file does, so we'll need to stage and then commit the ignore file. Let's move on to branching and merging. Branching is something almost all version control systems have. It allows you to work on a copy of the code in the main line without actually affecting the main line directly. For example, you would create a new branch if you were working on a bug fix or new feature. You're working in your own branch and everyone else can continue their work without being affected by what you're doing. But you still have all of the benefits of source control. When you're done, you would merge your changes back into the main line. Branching in Git is ridiculously easy. We can create a new branch using git branch and then giving the name of your new branch. A new branch is created and we can switch to it just as easily using git checkout followed by the branch name. Everything at this point will look exactly the same, but let's make 2 changes. Add a new file to the project and change our README file. And then we'll stage and commit the changes. To switch back to the main branch, we'll use git checkout master. Master is always the name of the main branch. When we switch back, take a look at the folder. We're missing our newly added CSS file. And our README is missing change 5. That's because the master branch doesn't have the changes we made in our other branch. Since we're done with our changes in the other branch, why don't we go ahead and merge them back into the master. Before we merge, we need to make sure that we're on the destination branch. In this case, master is the destination, and our new branch is the source. So use git status to see which branch we're currently in, and use git checkout master to switch to the master branch if we're not already there. Then all we have to do to merge is use git merge, and then the name of the source branch. Now we see our newly added CSS file in the project folder, and the README should now have change 5. Now while that merge was pretty smooth, most likely you're going to run into merge conflicts, and this is the part that everybody hates. So let's cause a conflict by adding change 6 to our README, and then committing the changes. But I'm going to show you a shortcut. When using -a in the commit command, you can skip the staging step. Any changes to files that are currently tracked will be automatically staged. However, any new files that are untracked won't be staged, and they'll have to be added manually using git add. Then we'll switch back over to our other branch and add change 7 to the README and commit those changes. This time, let's merge master into our new branch. When we do that, we see that there's now a merge conflict. We can also see this using git status. Git wasn't able to automatically perform a merge, and now it's up to us to take care of it and resolve the conflict. Examining the README file, we see some additional text. Git has put information about the conflict directly in our file. The top part is the head, which means the version in the current branch. The bottom part is the version of the source branch, in this case, the master branch. We can easily see what we need to do to fix this, so let's adjust the file and then remove the markers that Git added. Once we've resolved all the conflicts, we need to run git add to mark these files as resolved, and then we commit them. You can imagine how incredibly complex this process will get in an actual project. Don't worry, there are better ways. Once you get a merge conflict, you can use git merge tool to launch a tool to help make fixing merge conflicts a lot easier. However, at this point, I don't have any installed or configured on my machine. I highly recommend getting a merge tool like TorchSmerge or my personal favorite, WinMerge, and configure Git to use it so you don't have to try and tackle merges manually. There's plenty of documentation on configuring Git for a merge tool, so I'm not going to cover it here. Now that we've talked about branching, I want to show you a nice feature called stash. Let's say we're in our current branch and we add a file. You recall what happened previously when we added a file to one branch, it disappeared when we switched to the other branch. But what happens if we're in a branch and we make changes but don't commit them? In this case, the changes remain when we switch branches. As you might have guessed, this could be a big problem at some point. Let's say you're working on a branch and you've made a ton of changes and you're not ready to commit them yet, but you need to switch to another branch to do a quick bug fix or work on something else. As we just saw, your changes will persist during the branch change, which is going to be an issue. So what the stash command does is take the dirty state of your branch, including tracked modifications and staged changes, and saves it on a stack of unfinished changes that can be reapplied at any time. So before we switch branches, let's do a git status to see that we do have changes pending. Because we added a new file, it isn't being tracked yet, so it won't be included in the stash. So we'll just use git add to start tracking it. Now let's stash the changes using git stash. Using git status shows us there's no more pending changes. When you're ready to come back and continue your work on this branch, you can reapply your changes from the stash using git stash apply. Now you're ready to continue on. Okay, you pretty much know the basics now, so let's look at working with remote repositories. The terms used can be a little confusing, so I'll explain them and the differences as we go. First off, keep in mind that even though you're interacting with a remote repository, everything is still happening locally. You have to manually retrieve and push changes to the remote repository. We can see a list of existing remote repositories we have using git remote. At the moment, we don't have any listed. It's important to note that any remote repositories we add will only apply to our current local repository. And I'll show you what I mean in just a bit. Let's go find a repository on GitHub. I'll use a repo I created for my .NET project called FluentGuard. First, we need to get the clone URL, which GitHub provides us. Now back in the Git shell, We're going to clone the FluentGuard repository using git clone and providing the URL for the repository. When that's done, you'll notice a new folder called FluentGuard in our project folder. Cloning a repo does exactly what it implies. It pulls down the entire repository, including the entire commit history, and as such, Git puts everything in its own folder. If we use git remote right now, we'll see nothing just like before. But let's switch over to the FluentGuard folder and use git remote once more. Now we see an entry for origin. Let's use git remote with the -v argument to have Git show us the URLs. Origin is the default alias for the repo that was cloned. You'll use this alias when issuing Git commands instead of the URL. Now that we have the repository, we can start working with it. As time goes by, we'll need to keep it up to date, and there are two ways of doing that: by fetching and by pulling. Git fetch origin will go out to the server and get any changes made since you last cloned or fetched. Fetching will pull the data into your local repository, but will not merge it into your work. You'll need to merge manually. Using git pull origin will automatically fetch and merge the changes from the remote branch into your current branch. When you're ready to submit your changes, commit your work and then use git push origin master. We're telling Git here to push our changes to the remote repository known to us as origin and commit them to the master branch. At that point, you'll be prompted for credentials. I'm just going to put in some fake credentials here, so it's going to fail. Now at this point, any changes that you made will be committed to the remote repository. To add additional remote repositories, use git remote add followed by the name you want to give the remote repo or the alias, and then the URL. And just like before, you can name, just like we did with origin, from the cloned repo. There's quite a bit that I haven't covered, but what we did cover is enough to get you up and running quickly. Check out the Git documentation and also have a look at Pro Git, which is now available as a free ebook, and I'll put a link down in the description. Alright, that's it for this episode. Be sure to subscribe to our channel and check out previous and future episodes. If you have a request for an episode or you want to be a guest on an episode, send me an email at codeporn.show@gmail.com. Thanks for watching.